Okay, a very brief look at calculus 14, limit problem. So we're just going to plug this -1 into the x value. If you're not very good at arithmetic, we can use the calculator for this. So we're going to type in 2, open parentheses, -1, close parentheses, square it, plus 3, open parentheses. Don't forget it's a -1, close parentheses, and then plus 2, hit equals. So my answer would just be 1. Again, if you're good at arithmetic, you don't need to use the calculator, so this limit is just going to equal 1. Now this one's a little tricky. So I want to take the e and plug it in for x. So my limit as x approaches e of ln of x to the 5th is basically going to be ln of e to the 5th. Now I can do this in my head. ln and e cancel out. So my answer's just going to be 5. Again, if you don't trust that, you can actually use the calculator. So I'm going to hit the ln button. ln button's right over here. And then I'm going to hit shift ln. Shift ln. Shift ln is the e button. And the e is going to go in for the x. And that is going to be raised to the 5th. You don't have to close parentheses, but I'm going to. And notice it equals 5. So now this one's a little bit different. This one is the limit as x approaches ln of pi of e to the x. So the plug-in is going to be e to the ln of pi. Again, I can do this one in my head. The e and the ln cancel each other out, and your answer is just going to equal pi. Limit as x approaches 2 of 5x. So I'm going to take that 2 and plug it in for x. So that's going to give me 5 times 2. I'm not going to use the calculator on this one. That's going to give me 10. Average rate of change. Average rate of change is the slope formula. Slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now you have to be woke on this one. This is not an x value and a y value. This is an x value and another x value. So I have my values on the bottom for the slope. So I'm going to set up my slope template with my minus sign, my division bar, and my minus sign. And on the bottom, I'm going to put x sub 2, which is 4. On the bottom, I'm going to put my x sub 1, which is 1. Now I need to know what to put up in the top here. So I take this 4, and I plug it into the function. Some people say they plug it into the function here. You do. But over here, this is more realistic. 3 times 4 is 12. The 4 goes there. So 3 times 4 is 12. 12 plus 2 is 14. Then I take this 1 and I plug it into the function. So 3 times 1 is 3. 3 plus 1. 3 times 1 is 3. 3 plus 2 is 5. Now you want to do your basic arithmetic. So 14 minus 5 is 9. 4 minus 1 is 3. So 9/3 equals 3. Same move over here for number 6. Average rate of change. Slope formula. This is not an x value and a y value. This is an x value and another x value. So I'm going to set up my slope template. A lot of slope in calculus. Minus sign, my x sub 2 is 5. Minus my x sub 1 of 2. So I know already that that's going to be a 3 on the bottom. But I need to know what to put on the top here. So my y value is going to be 5 plugged in. So 5 squared is 25. 25 minus 3 is 22. Plug in the 2. 2 squared is 4. 4 minus 3 is 1. Do your simple arithmetic. 22 minus 1 is 21. Over 5 minus 2, that's 3. So my average rate of change is going to equal 7. Derivatives, power rule, 5 times 7, so y prime is going to equal 35x minus 1 to the 4th. The derivative of 2x is just plus 2. Derivative of ln. Derivative of ln. ln is a little tricky and not so tricky. A lot of copying in calculus. A lot of copying in calculus, so I just copy down the 7x to the 5th plus 2x. Now I wonder what goes on the top. What goes on the top is the derivative of the guts. So you got to do the power rule on the top. That's going to give me 35x to the 4th plus 2. So the ln derivative isn't really that difficult if you can remember the move. ln and radicals are closely related in algebra and calculus. So again, there's going to be a fraction bar. But in this case, you write down the hidden 2 in there for the square root. And then there's a lot of copying in calculus, so you're going to put 7x to the 5th plus 2x. Now you might be curious what goes on the top. So what goes on the top is going to be the derivative of the guts. So 5 times 7 is 35. X to the 4th minus 1 from the exponent plus 2. Product rule. Crack it down the middle like an egg. Make a T-chart. The derivative of 5x to the 7th is 35x to the 6th. This is strange. The derivative of e to the x is e to the x. Crisscross applesauce. So that's going to give me y prime equals 5x to the 7th times e to the x plus crisscross applesauce 35x to the 6th times e to the x. Not easy, but not that difficult. Number 11 can be done totally on the calculator. Number 11 can be done totally on the calculator. I'm going to do it by hand first. So we're going to do a thing called the antiderivative. So the derivative, you subtract 1 from the exponent. So the antiderivative, you would add 1 to the exponent. That would give me 8x to the 4th. The derivative, you would multiply by the exponent. So antiderivative, you divide by the exponent of 4. That's going to simplify to just 2x to the 4th. Now I'm going to evaluate it at 0 and 4. So when I plug 4 in, I'm going to actually use the calculator. 2 times 4 to the 4th. Let's see what that's going to generate. 2 parentheses 4, close parentheses to the 4th. Big number. 512. So this is going to equal 512. Now when I plug 0 in, that's going to equal 0. The calculus is going to be 512 minus 0. So my answer is going to equal 512. Let's go ahead and just use the calculator. So in order to use the calculator, you want to hit this button right here. Gotta be in normal mode. You gotta be in normal mode. So let's do mode 1 first to make sure we're in normal computational mode. We're going to hit that calculus button. We're going to type in 8 alpha red x to the 3rd power. So I have to hit X box to the 3rd power. Down arrow, start at 0. Up arrow, end at 4. And it's so convenient. It does the whole problem for you pretty rapidly. 512. All right, I want to find the antiderivative of negative cosecant cotangent evaluated from pi over 2 to 2 pi over 3. You can't use the calculator for this one because there's no cosecant button on the calculator. So I'm going to go to my cute little note. So in my cute little note, the derivative of secant was secant tan. The antiderivative of secant tan was secant. The derivative of cosecant is negative cosecant cotangent. So the antiderivative of negative cosecant cotangent is just cosecant. So the antiderivative of negative cosecant cotangent is just cosecant. So this is going to equal cosecant x evaluated from pi over 2 all the way up to 2 pi over 3. So I need to find out what cosecant of 2 pi over 3 is on my table. So cosecant 2 pi over 3 is going to be 2 root 3 over 3. So I'm going to write that down here, 2 root 3 over 3. Then I need to find out what cosecant of pi over 2 is. So cosecant pi over 2 is here. That's going to be 1. I don't know if you remember doing this, but when you get this number and this number, you just subtract them. And that is going to be your answer. 2 root 3 over 3 minus 1. No decimal, please.